This is video B27, and we'll start by looking at the solution to the problem that we're not going to talk through together. And then the problem that we will talk through together. This is B27, a no calculator problem. Okay, and so we're dealing with a Taylor polynomial. We have a function that has all derivatives of all orders. It's important to us at x equals 0, and that must be the center that we're looking for with this Taylor. So it's really a Maclaurin. And anyway, so it's known that when x is 0, y is -4, and that the first degree Taylor polynomial at 1/2 is -3. Okay, and we want to find the derivative at 0. I mean, we want to show that the derivative is 2 at 0. Okay, so don't forget, let's start with this. The nth degree term in a Taylor polynomial is the nth derivative, okay, at the center, that should be an A, times x minus a to the nth power all over n factorial. Okay, and so that means the first order, the first degree Taylor polynomial would be some constant times x to the 0, and that constant is just the 0th derivative, just the function, f of 0, and we're given that. Plus, and this is what makes it a first degree, we have x to the first degree, some constant times x to the first, and this constant would be the first derivative. Okay, and don't forget, you would have under this one a 0 factorial, under this one a 1 factorial, but they're both 1. And so I substitute in what I'm given. I'm told that p of 1 is -3. Okay, this is just -4 given to us right there. And we're looking for, if you think about it, that constant, which is the derivative. And we're dealing with this at x equals 1/2. And so I just solve for c sub 1, and that's the derivative I want. Okay, and then they give you the second and third derivative values, and they want the third degree Taylor polynomial. Okay, so we now know the first two terms of the Taylor polynomial, -4 from here and 2x from there. And then the next two terms would be the second derivative times x to the second over 2 factorial, plus the third derivative at x equals 0 times x cubed over 3 factorial. Okay, and they give us this, they give us that, and it's just a matter of simplifying it. And then part C. We're told that there's a function h, and its derivative is equal to f of 2x. So think about what that means. Its derivative is f of 2x. F of 2x is what we would get by plugging in where we have all these x's, just a 2x. And so that's how I start. H prime of x is -4, and then 2 times 2x, and then 2x squared, and so forth. I went a little too far. I didn't need this because I didn't read the rest of the question yet. Okay, and so let's read the rest of the question. Find the third degree Taylor polynomial for h. Okay, so you'll see why I know I can cut h prime off at the x squared term. The reason we can do that is because if h prime equals this and I want h, I need to anti-derive term by term. And the tricky part here, the part that I would guess most students would miss, we're anti-deriving. There's a big C. I just anti-derive term by term. Remember, we can derive and integrate term by term with Taylor polynomials. Anyway, so since we are finding an antiderivative, you need big C. Big C would be this constant term. Remember, a Taylor polynomial would typically start with a constant term. H is simply a Taylor polynomial. So this constant term out here is what we're given right there, H of 0. Just like f of 0 is -4, wherever I started it right here, we're given that. So this is a little tricky. All right, guys, that is the last that we'll be doing this way. Wait until next week and you'll see how we'll finish this thing up. Good luck with everything, everybody.